In previous video, we have considered the magnetic effects of current. When the current is passing through this wire and magnetic needle was kept below this wire, then this magnetic needle suffers deflection. If current is passing in this direction, then north pole of magnetic needle will deflect towards west. And if we are changing the direction of current, then direction of deflection also changes. Also, we found that the amount of deflection can be increased by increasing the strength of current flowing through this wire. And if we will stop the flow of current, then magnetic needle will come to its normal position under the effect of Earth's magnetic field. The direction of deflection can also be changed if we will place the wire below this magnetic field. All these activities were suggesting that as this magnetic needle is deflected, when the current is passing through the wire, it means this current carrying wire is going to behave like a magnet. Also, we read that when the current is passing through a straight wire and this wire is passing through this cardboard, then compass needle is going to arrange themselves in the form of concentric circles, or if we are going to put iron fillings here, then we can have many concentric circles which are close to each other near the wire, and as you will go away from the wire, gap between these circles will increase. Next, what we did, that if a charged particle with a charge q is moving in presence of electric field and magnetic field, then it will experience a force. The total force will be equal to force due to electric field, force due to magnetic field, and the value of these forces, due to electric field it was QE and due to magnetic field it was QV cross B. Today we will consider this particular part, magnetic force, in detail, and we will have few definitions. So, magnetic force can be written as QV cross B, which further can be written as QVB sin theta. So, what we are going to have here, this magnetic force can be written as QVB sin theta. If we will find the unit of magnetic field, then it will be Fm divided by QV. Unit of force will be Newton, unit of charge will be Coulomb, unit of velocity will be meter per second. This second will come here, charge per unit time will give you current. So unit of magnetic field is coming out to be Newton upon ampere meter, which is Newton ampere inverse meter inverse, which is equal to Tesla. About this we will consider after 2-3 minutes. Before that, we will consider magnetic field strength. What do you understand by term magnetic field strength? If value of charge is 1 coulomb and the charge is moving with velocity 1 meter per second at an angle 90 degree with the magnetic field, then in that case this factor will be 1, this will be 1, this will be 1, and Fm will be equal to B. It means this magnetic field is numerically equal to force experienced by a particle with a charge 1 coulomb, and this charge of 1 coulomb is moving with velocity 1 meter per second in a direction perpendicular to the direction of magnetic field. So from here we can have definition of magnetic field strength or magnetic field, which is equal to force experienced by a particle with charge 1 coulomb moving with the velocity of 1 meter per second at right angle to the magnetic field. Now to define the strength of this magnetic field, we have unit also, and this unit is known as 1 Tesla. If this force experienced is 1 Newton, then magnetic field strength is said to be 1 Tesla. So in order to define 1 Tesla, we will consider this equation again, and everything here we will make unity. Force experienced 1 Newton, charge 1 coulomb, velocity 1 meter per second, sin theta also 1, and sin theta will be 1 when theta is going to be 90 degree. So the magnetic field is said to be 1 Tesla if a particle of 1 coulomb moving with the velocity of 1 meter per second perpendicular to magnetic field is going to experience a force of 1 Newton. With 1 Tesla, we are going to have one more unit of magnetic field, that is Gauss. And 1 Gauss is equal to 10 raised to power minus 4 Tesla. This factor you have to use when you will solve the numericals. So if we will recall what we have done till now, or we will conclude the different equations, then we can have the total force can be given by force due to electric field, force due to magnetic field, that will be equal to QE plus QV cross B. Now force that is acting due to electric field is independent of velocity, whether particle is at rest or it is in motion. Force is dependent on magnitude of charge and it will depend on electric field. It is independent of the fact that whether your charged particle is at rest or it is in motion. But force due to magnetic field is dependent on velocity. If particle is at rest, then force due to magnetic field will become 0. So if a particle is at rest, it will experience force due to electric field. If it is in motion, then it will experience force due to electric field as well as due to magnetic field. Due to electric field, either charge will accelerate or charge will retard. Its direction of motion will not change. It means either there will be increment in its speed or there will be decrease, but due to presence of magnetic field, there will be change in direction of motion, because this force will act in a direction perpendicular to the direction of velocity and magnetic field. So this can change the path followed, but it will change only the speed with which the particle is moving. So related to this, you can have 1 mark conceptual questions. After this, what we are going to do, the important article is how to find the value of a force that is acting on a current carrying conductor when it is kept in a magnetic field. This is current carrying conductor with length L, area of cross section A, through which I current is flowing, and N is representing the number density of free electrons. It means number of electrons in unit volume. Vd is representing drift velocity of electron and E is representing magnitude of charge present on electron. In second unit current electricity, we have done relation between current and drift velocity, that was I is equal to NEAVD. Again, see this diagram. This is current carrying conductor PQ with length L, which is kept along y-axis, through which current I is flowing. It is with length L and area of cross section A. N, small n, is representing number density of electrons. Vd is representing drift velocity with which electrons are moving. E is representing charge on electron. So current flowing through wire will be NEAVD. Multiply both sides by L. It will be IL, that is equal to NEALVD. Now I want to write this in vector form. Velocity also and this IL also. So this IL with vector will become current element vector, whose direction will be same as the direction of flow of current. Now current flows in a direction opposite to flow of electrons. If electrons are flowing in this direction, current will flow in this direction. So direction of IL and VD will be opposite. So when we will use vector, negative sign will come in this equation. IL with vector will be equal to minus NALE VD vector. Now we were searching for an expression where we will find the total force acting on a current carrying conductor. How this current carrying conductor will experience a force. Current carrying conductor means electrons are flowing. Electrons are flowing means charge is flowing, and charge is flowing here in presence of magnetic field B that we have applied along z-axis. So many charged particles are moving in this wire all particles will experience a force due to presence of magnetic field. So we have to find what is the total force experienced by these charged particles. For this, first we have to find how many total charged particles are moving here. For this we will consider as N is representing number of free electrons per unit volume, and N means this is total number of electrons divided by volume. So what is the volume of this wire, which is with length L and area of cross section A? This volume will become A multiplied by L. This is number density. This is representing capital N, total number of electrons. So total number of electrons will come with us N multiplied by AL. So total number of electrons will be NAL. Now we will find what is the force experienced by one electron. Then we will multiply that equation with total number of electrons. That will give us the total force acting on the wire in presence of magnetic field. Using Lorentz equation, the force acting on electron which is moving with velocity Vd in presence of magnetic field B will be given by minus E Vd cross B. Why minus sign here? Because electron is negatively charged particle. If proton will move, then this will become plus. So magnetic Lorentz force on electron will be minus E Vd cross B. This is force experienced by one electron. How many total electrons? NAL. So total force will be, this will be multiplied by this. So we are going to have N multiplied by minus E Vd cross B. So it will become NAL minus E Vd cross B. This equation we are writing like this, minus NAL E Vd cross B. Now this part I can replace by IL by using equation number first. So what will come with us is this I will replace by IL. So equation will become IL cross B, which can be written as ILB sin theta. This will give me the magnitude of force acting on the wire, where theta will be the angle between direction of current and direction of magnetic field. If I will consider here theta is equal to 0, then in that case force experienced will be 0. If theta is 180, then also force experienced is going to be 0. Maximum force will be experienced if this wire is kept perpendicular or the current is flowing in a direction perpendicular to the direction of magnetic field. Maximum will be when angle between I and B will be 90 degree and force will be 0 when angle between I and B is going to be either 0 or going to be 180 degree. This equation gives magnitude of force, but force is a vector quantity. How to find the direction of force? To find the direction of force, we are going to have Fleming's left hand rule, which you can learn by simply learning one term, that is FBI. FBI means what you are supposed to do, you will stretch the thumb, forefinger and central finger of your left hand such that they are mutually perpendicular to each other. Now just remember FBI. FBI means thumb is representing the direction of force acting on the wire. B, this finger is representing the direction of magnetic field and your central finger is representing the direction of current flowing. So stretch your thumb, forefinger and central finger of your left hand mutually perpendicular to each other. Remember FBI. FBI means thumb will give direction of force acting on the wire. B means it will give the direction of magnetic field and I means your central finger will give the direction of current. So you are supposed to do example 4.1 and 4.2 in your NCERT book.